So in this short tutorial, we're going to look at digital inputs. That is reading the state of a pin that where its voltage, whether it's 5 volts or 0, is set by the external circuit. And we'll look at the most common way we do that, which is with a push button switch. So what you're seeing here on the screen is a figure from a software package called Fritzing. Fritzing is developed in Europe, and it is open source, which means you can download the source and compile it yourself for free. You can distribute it. They have recently set up a paywall behind downloading the executable. So I had to pay, I think, €8 through PayPal to get the executable. I am trying to get permission to distribute the executable to you, so hang with me until I get that permission. In the meantime, you can just Google Fritzing and find the download page, and if you've got a PayPal account, plunk down your €8, which is what, $10, $12, and you're good. So let's look at this. What we've got here on the breadboard, I've got 5 volts from the Arduino board to this row here with the red line. I've got the ground going to the blue line here. I've got a circuit that starts at 5 volts, goes through a 1K resistor, goes through a push button, and then back to ground. And then at the junction between the resistor and the push button, I tap that off and go to pin 3. Sometimes it's a little hard to see, so Fritzing also allows you to look at the kind of a more schematic view. I'm going to zoom out a little bit so you can see this. And so we have 5 volts, 1K resistor through the push button to ground, right? And then at the junction between the resistor and the push button, I've tapped that off and gone into pin 3. So that's all well and good. Now, and so the idea here is I'm going to read the state of the push button. So if the push button is open, there's really no circuit. Remember, this is going to be configured as input, which if something's configured as input to the computer, it's got very high impedance or high input resistance. It won't allow any current or very much current to flow, which means if this is at 5 volts on this side of my resistor, then this will also be 5 volts with very little current. There's very little voltage drop, right? So it'll read it as high. When you press the push button, it completes the circuit through 5 volts, through the resistor to ground, meaning it's going to drop all that 5 volts across here because there's very little resistance in the push button, and then that pin will read close to 0. So pin open, 5 volts or high, pin closed, 0 volts or low. So we can write a program about how to do that, but it will be uninteresting because we're not doing anything with it. So let me add to this circuit a little bit, and let me have an LED. And so what we'll do is we'll mimic. We'll have the LED get turned on and off depending on how the push button is. So I'm going into Fritzing. I say, yeah, find me an LED. They've got lots of parts here, a lot more than I need. I'm just going to grab this guy as soon as it's done searching. It's got to go through all the library. Okay, so I'll grab that one here, and I'll put that here. Let's see. It's not telling me which is positive and which is negative. Okay, and I need a resistor. And we'll just grab one of these guys here. And now we just have to, so oh, there's the notch. This is the longer lead here. So the longer lead will go to 5 volts, and the resistor will go to oh, actually, I did that wrong. This doesn't go to 5 volts. This goes to our pin, right? So I'm going to take that to pin 10. Okay, and I don't like the colors here. Anything that's ground should really be black. And anything that's kind of a signal should not be black or red, so I will choose orange. Okay. So so here's what I want. I want to be able to read the state of this push button and reflect it in the LED. Okay, pretty straightforward. So so when I push the button on and off, the LED should go on or off. So let's move over to the Arduino environment. And I'm going to start a new sketch. Get the other one out of the way. And I want to set the 2 pins as constants, right? So constant integer, my input pin to be 3, right? That's what I had set up the input to be. And the output was on pin 10. Okay, so the LED was hooked up to 10, the push button was hooked up to 3. So I've got that set up. Now I need to set the mode of those pins. The compiler needs to know in advance, are they input or output? So my input pin is, of course, input. Notice that when I enter in these keywords, pin mode and input or output, the color changes, representing the fact that it recognizes these as special, what we call them tokens or special symbols for the compiler. So pretty straightforward. Now, in the loop, I have to store this somewhere, right? I have to store this. We have the digital read. But it doesn't say where it goes. In other words, we need to store whether it's high or low. And let's go back to our language reference and talk about that a second. So let's go back to our language reference and look at our digital read information here, right? So so here's the page on the digital read. Reads a value from a specified digital pin, either high or low. The syntax is digital read pin. And it returns high or low, which means when you actually use it, and here's the call for it. There's my digital read pin, but I have to set the result of that equal to some variable name, right? And in here they called it value, and they declared it as an integer, and they actually declared it as a value to initialize it. So let me go back to Arduino, and we'll do that. We'll say, okay. I'm going to say int val equals 0. Now it's not a constant because I'm going to be changing variable or changing its value. So now that statement looks correct. So the val, this will return a high or a low depending on what the state of the push button is. So now we can call digital write, and that's done this way, right? Pin number, my output pin, comma, val. So what would happen? So remember, so val goes to 1 when the push button's not pressed, right? So if it's not pressed, it'll return a high, and then it'll write out a high to that output pin, which means it'll light the light. And if it's the other way around, if you press the button, then it reads a low and it'll turn the light off. So this will be without pressing the button, the light's on, LED's on. When you press the button, the LED goes off. I'll leave it as an exercise to you to how to change that behavior, how to flip that around. So that's it in a nutshell. That's how you get a digital input. And a little introduction into fritzing as well.